There's the SAT problem, College Board question. May want to pause here. 24 out of 27 it's going to be a harder one. Now, system of equations, ordinarily I would just type this in Desmos, but we've got this A right here. In a given system of equations, A is a constant. The graphs of the equations in the given system intersect at exactly 1 point. Okay, so what's the value of X? Okay, so they intersect in exactly 1 point. So that means that it's not a no solution case, and it's not an infinite number of solutions case. Now, if you'll notice, this is a parabola. You can tell because it's x squared. This is a line. So it's impossible to have, you could either have 0, 1, or 2 solutions. So what I'm going to do here, and I don't do these beforehand. I just think about them when I first see them. I'm just going to set it up like this. I'm going to set them equal to each other. Okay, 3x plus a. And I'm going to subtract. Anytime you have a quadratic, if you're solving this by hand, quadratics, if you have x squared and x together, then you're going to want the number 0. Just a little tip there. So I'm going to subtract a. Okay, so when I do that, sorry, I don't want to write 2x squared here. I'm going to get 2x squared. I'm going to get a negative 24x. And I got this 64 minus a. That's equal to 0. And I know that this will intersect in exactly 1 point, which means that it looks kind of like this. You got a parabola going somehow, and you got a point. It's just going to hit one time. Now, if it hits one time, that means when you factor this, it's what we call a perfect square trinomial. A perfect square trinomial. So let's divide these by 2. X squared minus 12x plus 32. The reason I'm dividing by 2 makes it easier to factor. And plus, I can do that for free here because I've got this 0. If I do 0 divided by 2, it's still 0. Now, another problem is we've got this a, so it's now a over 2. But what we want to do is get a perfect square trinomial. So that means that this number right here, this value right here, should be half of this squared. That's how a perfect square trinomial looks. Let me show you some perfect square trinomials in a different color, just to give you a little background. So perfect square trinomial would be x squared minus 2x plus 1. X squared minus 4x plus 4. X squared minus 6x plus 9. Each time what I'm doing here, I'm taking half of that number. It doesn't have to be minus. I'm just doing minus because ours is half of that number squared. If you know the process of completing the square, that's what that is. Half of that squared is 4. Half of that would be 3. Square would be 9. Because if you factor each of these, you get the same thing twice. Right, that's x minus 3 squared. This one's x minus 2 squared, and so forth. X minus 1 squared. All right. And the reason I can only have one solution. I can't have 2 because it only touches once. So I need this to be half of 12 squared. That's going to be 36. So I need 32 minus a over 2. I need that to be 36. And actually, we don't care what a is. We just care what is x. What's the value of x? So we know for this to work out, this has got to be x squared minus 12x plus 36. All right, and if you factor that, that's going to be x minus 6 squared. All right, and if you solve that, that's going to be 6. So the correct answer is going to be 6 for that. Now, this is more difficult to type in the Desmos because the test makers are clever here. They know that folks are going to, some of the easier questions, you can just type it in the Desmos. That would be hard to do here. You could come up with a slider, I guess, and work it. But being that fancy in Desmos would probably eat up too much time anyway to come up with that. So knowing the process of completing the square and knowing what a perfect square trinomial, those things you learn in class, they really turn out handy here. So C is the correct answer.